Have you ever wondered why a giant ship made of steel can float while a tiny pebble sinks straight to the bottom? It's all about the science of flotation. Flotation is the ability of an object to stay afloat in a liquid like water. It's a super important concept that affects tons of things in our world, from the boats we sail to the way things are designed and built. Understanding flotation helps us understand why things behave the way they do in water. It also helps us design and build things that can float, like ships, life jackets, and even floating cities. So let's dive in and explore the fascinating world of flotation.
The story of flotation starts with a Greek dude named Archimedes. Legend has it that he hopped in the bathtub one day and noticed the water level rising. "Eureka!" he shouted, which basically means, "I've found it." What he found was the principle of buoyancy, which explains why things float. Archimedes' principle states that when an object is submerged in a fluid, it experiences an upward force called the buoyant force. This force is equal to the weight of the fluid displaced by the object. In simpler words, when something goes into water, the water pushes back up with a force equal to the weight of the water that the object pushed aside.
So how does buoyancy determine if something floats or sinks? It's a fascinating concept that has everything to do with density and the forces at play in fluids. That's where density comes in. Density is a measure of how much mass is contained in a given volume. It's a crucial factor in understanding buoyancy. Density is how much mass is packed into a given volume. For instance, if you have two objects of the same size but different masses, the one with more mass is denser. Think about a bowling ball and a beach ball. They might look similar in size, but their densities are vastly different. They might be the same size, but the bowling ball is much heavier because it has more mass packed into the same space. This makes the bowling ball denser. If an object is denser than the fluid it's in, it will sink. This is because the weight of the object is greater than the buoyant force pushing up on it. This is because the weight of the object is greater than the buoyant force pushing up on it. The denser object displaces less fluid, resulting in a weaker buoyant force. But if an object is less dense than the fluid, it will float. This happens because the object displaces more fluid, creating a stronger buoyant force. That's because the buoyant force pushing up is stronger than the object's weight pulling it down. Understanding these principles helps explain why some objects float while others sink.
Section 4. Shape Up, How Form Affects Flotation. In this section we will explore how the shape of an object can influence its ability to float or sink in water. While density is a crucial factor, the form of an object can be just as important. Density isn't the only factor in flotation. The shape of an object can significantly affect its buoyancy. For instance, a flat, wide object will float more easily than a compact, dense one. The shape of an object also plays a big role. Objects with a larger surface area in contact with the water tend to float better. This is because they displace more water, which increases the buoyant force acting on them. Take a look at a steel ship. Despite being made of dense steel, these ships are designed to float. The secret lies in their shape and structure. Even though steel is denser than water, the ship floats because of its shape. The hull is designed to displace a large volume of water, which creates enough buoyant force to keep the ship afloat. The hull of the ship is designed to displace a large amount of water, creating enough buoyant force to support its weight. This principle is known as Archimedes Principle, which states that the buoyant force on an object is equal to the weight of the water it displaces. This is why you can make a piece of aluminum foil sink if you crumple it up into a ball. When crumpled, the foil has a smaller surface area and displaces less water. When it's crumpled, it displaces less water, resulting in less buoyant force. The reduced displacement means the foil cannot generate enough buoyant force to counteract its weight, causing it to sink. But if you shape that same foil into a boat-like form, it can float because it displaces more water and increases the buoyant force. The larger surface area in contact with the water allows it to support its weight, demonstrating how shape can influence flotation.
Section 5. Flotation in action, from ships to oil spills. Flotation is everywhere. It's a fundamental principle that we encounter in various forms and scenarios, both in our daily lives and in specialized fields. We see it in action every day. From the boats we use for leisure or transport to the life jackets that ensure our safety in water, flotation is a key concept. Ships, as we've discussed, are designed to displace enough water to stay afloat. This principle allows massive cargo ships and luxurious cruise liners to traverse the oceans, carrying goods and passengers across vast distances. Life jackets are filled with materials less dense than water, increasing your overall buoyancy and helping you stay above water. They are essential safety devices that can save lives in emergency situations. Submarines can control their buoyancy by adjusting the amount of water in their ballast tanks. This allows them to dive deep into the ocean or surface as needed, making them versatile tools for exploration and defense. In mining, a process called flotation separation is used to separate minerals based on their density. This technique is crucial for extracting valuable resources from the earth efficiently. And when there's an oil spill, floating booms are used to contain the oil, which is less dense than water. These booms prevent the spread of oil, making cleanup efforts more manageable and protecting marine life. Let's not forget the formula for density. Density equals mass divided by volume. This fundamental equation helps us understand the behavior of different materials in water. This simple formula helps us understand why a giant cruise ship can float while a rock sinks to the bottom of the lake. It's all about science. Understanding these principles not only satisfies our curiosity, but also has practical applications in engineering, safety, and environmental protection.